pull out the chat to the side just so I can see it in case it does. Things come in through the chat, and we'll give it maybe another minute before we get started. Okay, we're 3 minutes after, and I think the numbers are still going up, but let's get started because there were actually some many good questions this week. So welcome to week 2. This week we'll be talking about variant curation. And for an agenda similar to last week, we're going to start with questions prepared ahead of time from the Google form group by topic, and then we should have a little bit of. Oh, am I not on camera? Oh, sorry, Waffy, you're talking to someone else. Um, and then if time, live questions. I think we should have some time for live questions. And I just want to thank you all for accommodating my time zone request. All of the questions came in by yesterday, by Thursday. So that was very much appreciated. It gave me plenty of time to prepare. And I also really wanted to thank you for some great questions. You are doing a wonderful job in this workshop, and it seems like there's a very high level of understanding, and that's very exciting to me because variant curation, I get very excited about it. So I think we're going to have some really good discussion today. So thank you for those great questions. They'll definitely tee us off with some interesting things to talk about.
Actually, Marina, I closed survey after 5 p.m. yesterday. That's why we
Okay.
didn't.
Well, there still were plenty of questions by then, so that's probably why. There weren't more, but there were still plenty of questions by then. So I wanted to thank everyone for getting those in before it was closed. But thank you for closing it too. Okay, so before I get started with any of the questions, I wanted to say, because it really based on the questions you were asking, it seemed like that we have some quite advanced learners here. So I wanted to put the plug out there for advanced learners. ClinGen has actually written clarifications or additions to many of the classification codes, and they can be found on the ClinGen Variant Classification Working Group website. And I'm going to open that up in a second and show you. And then also, ClinGen, as you've heard, has variant curation expert panels, and they've also written disease-specific specifications for these codes, and these can all be viewed at the ClinGen Criteria Specification Registry, or the CSPEC, and I'm going to pull that up too. So if you go to clinicalgenome.org and you want to find those additional resources, which I'll refer to many of them in the questions, that really built upon the ACMG 2015 guidelines, because those were a bit general, you can go to clinicalgenome.org and then working groups and variant classification. Sorry, I gotta scroll all the way to the variant classification working group, which is second from the bottom. Click on that and then scroll down to get to variant classification guidance. Click on that, and then you'll see many specific recommendations based on codes, and these will take you to the abstract for the publication and then a link out to the citation. And I would say a majority of these are open access, so you shouldn't have paywall issues. However, if you run into anything, feel free to email me. I should be able to get you access. But so there are many additional updates to particular criteria that were a bit flexible within the guidelines. So just pointing this out. And then I also wanted to point you to the criteria specification registry. So if you go to cspec.genome.network, you can go to the criteria specification registry and you can search by gene. So at this point, we have 200 different specification documents, so 200 different genes. So you can search by gene. You could search by disease if you wanted to there. And another way that's really interesting that you could consider if you're trying to develop your own rules within your laboratory is you can search by criteria codes. So if you go up to views and click criteria code summary, let's say you wanted to think about computational predictors. That's PP3 and BP4. You can search PP3 and this will pull up all of the specific rules from all of the expert panels for those particular codes so that you can see what all of the expert panels are doing across that code. I often use this for setting rules within my clinical lab or when I'm working with new expert panels to consider how other expert panels did it. But if we go back to the standard view, which is this, and we click on one of the documents, if you just click on the little bullets here to see the specifications, you can look through all of their different specifications to see how they've specified for, in this case, using classifying variants in ABCA4. So this can be really helpful. For example, many of the ACMG secondary findings genes or cancer genes are already present in this set criteria specification registry. So I often in my clinical lab will default to what an expert panel has set for their rules for a particular gene because they know best. And I'm doing genome analysis and looking at all of the genes. So I'll often default to what expert panels are saying. So this can be a useful resource. Okay, so let's go to the questions. So some of the first questions centered around functional studies. So the first one is how did we differentiate between PS3, which is functional evidence strong pathogenic, and BS3, functional evidence strong benign, when functional assay results are inconsistent across studies? It's a great question. So ClinGen has written additional guidance for this code. It's in the Burnich et al. Paper, and I have pulled out specific PubMed IDs if you want a particular PubMed ID, but also I encourage you to go to that website so that you can see all of the different specifications. So this Burnich et al. Paper details the suggested rigor with which to evaluate experimental studies. So it suggests the number of known pathogenic variants and known benign variants that should be used to validate an assay type, and also positive and negative controls, um, so that you can really evaluate if an assay is particularly rigorous. In my expert panels, often when assays are conflicting, we do not apply any codes unless one assay is really better controlled and more rigorous than another. So if you have conflicting assays, oftentimes we will say there is conflicting functional evidence and not apply any codes. Whereas if you had one assay that was not well done, it wasn't well controlled, when you read it, you don't think it's rigorous, you could potentially discount that assay if that assay was saying that the variant had a benign effect and maybe three other very well done assays are saying pathogenic. And that's a case when you can use a little bit of expert judgment or so your own skilled opinion potentially in that case. But also expert panels will suggest which studies are rigorous in their specifications. So if you happen to be evaluating variants in a gene that has an expert panel, please take a look at that because they do very rigorously evaluate their functional studies to say if they should be applied at supporting, if they should be applied at moderate, if you could count multiple functional studies. So you're in luck if you have an expert panel that's specified for your gene of interest. Okay, next question about functional studies is how can we use empirical calibration to assign specific point values to emerging data types, such as high throughput functional assays, so MAVES, to ensure they fit into the existing strength categories? So that's a great question, and it's something that ClinGen's actively working on. So we recently partnered with the Alliance of Variant Effects, AVE, and this is a group that really has been displaying, generating, evaluating MAVE data to develop guidelines for evaluating and weighing MAVE data. So I will say that some ClinGen VSEPs do already accept MAVE assays. So take a look if your gene of interest has an expert panel that has specifications and they hopefully have a intensely evaluated functional data. So for example, the familial hypercholesterolemia expert panel that has specifications for LDLR does already accept MAVE assays at a supporting level, and they have requirements written for that. So much like the rigor that you need to use to evaluate functional data in the Burnich et al. Paper that I just talked about, we're working on guidance to suggest the same type of rigor, but it definitely is appropriate if MAVE assays are well characterized and rigorous that they should be used within the framework. In general, I am a lab director. I'm a clinical molecular geneticist. I sign out cases on a daily basis. In general, I tend to be conservative when I'm not sure how rigorous exactly an assay is. So I would say it's maybe a good idea to start at a supporting weight unless an expert panel is telling you otherwise, or if you're an expert in that particular area and really can assess how rigorous a MAVE assay is for a particular disease area. Okay, so the next couple sets of questions are for computational predictors. So the first one is for criteria like PP3 or BP4. These are computational predictors suggest pathogenic, which is the first one, and computational predictors suggest benign, which is the second one. How do we determine which in silico tools are considered sufficiently validated to use? That's a great question. That's a question that many of our expert panels have asked. So we have actually written additional calibration guidance for functional tools for missense variants. We're working across other variants too, but I've included the citation for this for the Pejiver et al. Paper for suggested tools as well as suggested cutoffs actually for benign and pathogenic ranges, because even if someone had a favorite tool, sometimes it wasn't always clear what the cutoff should be for benign and pathogenic ranges. And I will say that many of the ClinGen VSEPs at this time use Rebel as a meta predictor as their predictor. And they have slightly varying cutoffs, but usually it's 0.7 or greater for pathogenic classification. And if I remember correctly, it's 0.15 or lower for a benign. And in between is kind of, you don't get any pathogenic or benign codes there, but definitely take a look at that publication. And I will say, as you probably know, the computational prediction field is a rapidly evaluating field. And so we do have a computational prediction working group within ClinGen that will continue to evaluate tools like alpha missense, for example, as things are released and algorithms become better and better with predictions. Okay, another computational question. What tools would you suggest to assess impact of splicing variants as well as identifying cryptic splice sites? So this is the same thing. So ClinGen has provided some guidance on which splicing prediction tools to use. And that publication is Walker et al. And there's the PubMed ID. And many of the VSEPs at this time use Splice AI as their computational prediction tool for splice variants. But the same as with missense variants, we do have a group that will continuously evaluate any new splicing prediction tools that evolve and provide some guidance on those. So take a look at this publication if you have questions about splicing predictors. Okay, the next question is about hotspots. So regarding the application of PM1, which is the hotspot code, so found in an area of where pathogenic variation is constrained and there's not benign variants present, is use of software such as Decipher Genome Viewer to visualize variant distribution. So for example, path, likely path, uncertain significance, likely benign and benign variants across a gene to really find that that area that has only pathogenic and likely pathogenic variants and not benign variants, and suggesting a hotspot that way. As demonstrated as boxes or triangles or different shades adequate to estimate a region as a hotspot without benign variation subjectively? Or is there a more formalized manner to assess this criteria? This is a great question. I think this is one that I struggle with. As I mentioned, I do genome analysis, and so I am required to be signing out variants across all different genes compared to in my training when we really were experts in particular gene panels, for example, and you just knew the genes really well. So I would say as a laboratory director, I tend to be conservative here and not apply codes unless I'm really sure about them, because as you can imagine, those really could bump a variant from uncertain significance to likely pathogenic, and I want to make sure that's warranted. So a couple answers here. If you happen to be looking at a gene with a VSEP, you're in luck. They've defined their hotspots. Um, if you don't have a gene that has a VSEP, in general, I often look for published evidence before designating hotspots. So not only just published case level data in a particular region, but also functional experiments really suggesting why a region might be a hotspot before I apply, because this is a moderate piece of pathogenic evidence, which is not nothing compared to supporting, which would be a computational predictor, for example. That's a little lower. You need quite a bit of supporting evidence to get to a likely pathogenic classification, but moderate is definitely stronger than that, and you can get to likely pathogenic a little bit more easily. So I am conservative in this application. So I have worked with many VSEPs to develop their specifications, and some VSEPs, some of my VSEPs have done basically what is suggested, but a bit more formal, where we do an analysis of nomad and ClinVar variant distribution. So we'll look at all the high frequency, likely benign and benign variants in nomad, setting our own cutoff and see where they cluster. And then also look at 2-star ClinVar variants that are likely pathogenic or pathogenic and see where they cluster, and see if there's any particular region that is devoid of benign or likely benign variants and really has a bunch of likely path and path variants clustering in that region. However, this is a big lift. Um, and this really would only be practical if you're doing a few genes, or maybe a panel worth of genes, to have this analysis done ahead of time to set PM1. Okay. The next question is population, related to population data. And I kind of had a flavor of this question across multiple individuals. So when a variant has conflicting population frequency data between nomad and a local population database, which source should be prioritized? So we know that population databases have skewed representation. We've talked about this previously. So given discrepancies, let's say, I would say probably the more common case would be your variant's absent from nomad, but it's present in high frequency in your local database. I would say that's probably the most common case, um, because maybe there's not the correct representation of your local population within nomad. You should always choose the database with higher frequency, because the if a variant is frequent in a control population or a healthy population, this is suggesting that it is not rare enough to cause rare monogenic disease. So you really always want to look for the maximum frequency within a population database. We're always worried that absence may just be because the variant was not sequenced or represented in a biobank or population database. So is the variant absent from nomad because there's just not well representation of the region where the variant is more common? But I will say the only caveat here is that a local population database needs to be large enough to count frequencies. And in general, we're saying the cutoff for that is at least 2,000 alleles to calculate frequencies. Because if you have 50 individuals, for example, it's really hard to get a read on how frequent that is, compared to hundreds to thousands of individuals, which may not always be practical. But if you get a sense, even if you have a small biobank or a small local database and the variant is really frequent in potentially healthy individuals in that population, I would not apply PM2, even if it doesn't meet the size to potentially apply BS1 or BA1 of like a benign variant, I would mention something in my evidence summary and say that this variant is present in X out of X individuals. So let's say 25 out of 50 individuals that have been phenotyped to be healthy in a local population database and not apply any codes. But you should always look for the highest frequency within a population. If you see it in the other direction, where you're seeing that a variant is high frequency in nomad and absent from your local population database, you should go with the nomad frequency, because if a variant is frequent in any population, it's not causing monogenic disease, rare monogenic disease. It might still be associated with complex disease, and that's for a different discussion for a different day. We're talking about monogenic rare disease, but you should always go with the frequency that's a higher in whichever population that's higher. That makes sense. Okay, so another question for population data. When does absence of the variant in population databases qualify for PM2, and when does it not? We were just talking about this, that just because a variant is absent from a database does not mean it is pathogenic. It might just mean that your variant is present in a population that's not well represented in a biobank. Um, we will say that at least if a variant appears to be rare in population databases, it is not too frequent to cause disease. So that's maybe a bit of a gating factor, that you should always check the frequency of a variant. But in the future guidelines, we're actually getting rid of this absence criteria as a piece of pathogenic evidence on its own. So um, kind of as a step towards this, ClinGen now suggests to reduce PM2, which is a moderate piece of pathogenic evidence, to supporting, because absence doesn't necessarily indicate pathogenicity. That being said, if you're looking at a variant in a patient from a population that is not well represented in NOMAD, you may not want to apply PM2. Let's say your population really is missing from NOMAD. Maybe it's not a good idea to say that this variant is absent in population databases, because they don't well represent your population of interest. And maybe you should be looking in your local population database as a better proxy. Another thing that's important is you should also additionally confirm that your variant is well covered in NOMAD and is not absent from there because sequencing is not good in that region. So if you're looking at a variant in a tricky gene, or a variant that has in a place that has high homology in NOMAD, or sorry, high homology in the gene, it may not be well represented in NOMAD. And there is a coverage plot that you can look at in NOMAD. And I realize I put here, see in the next slide for an example, and then I just didn't include the example here. So I can show you that if you go to a variant, let's go to a variant. When you go to your variant of interest, you can go to the genotype quality metrics at the very bottom here. So this one is present in NOMAD, but you can go to the genotype quality metrics and look at the depth. And you want to make sure that on average, the coverage in this region is about 30 to 35. And you can see that the coverage is mostly close to that or better in this, suggesting that you don't necessarily have a coverage issue here. That being said, if your variant of interest, let me see if I can try to do this. And if it will let me. I should have grabbed a variant that was absent from NOMAD. So if your variant is absent from NOMAD, it'll just show a coverage. It'll basically just show the coverage graph here and show you that the region is covered or not. And so you should always search for your variant in NOMAD and look and make sure that your region is covered if you're going to apply absence, because you just want to make sure that it was truly absent and not absent because of a technical issue. Okay. So now we have some general classification questions. So how should we approach classification when only one type of evidence is available? For example, computational predictors or only population level data. So for each variant you curate, you should really look for all publicly available evidence. And I would say many variants end up as VUSs because they don't have they only have one piece of evidence. Maybe they only have a damaging computational prediction. Maybe they are low frequency in a population database. Those would likely end up as a VUS. This is common. Um, and not, all variants won't necessarily have tons and tons of publications or tons and tons of information to get you to likely pathogenic or pathogenic. Um, you know, rare disease is rare. So you are going to end up with variants that don't have very much information. And those ones, at least for now, likely have to stay as a variant of uncertain significance or VUS. Okay, next question. For general classification questions, how should we classify variants identified during carrier screening when phenotype information is unavailable? So I really want to point out this distinction because this is a common confusion across all learners that I've seen, clinicians, and all levels of expertise. So we have a couple things that we talk about: classification and interpretation. And so when I talk about classification, that's evaluating the available evidence for a variant. So is there a damage in computational prediction? Is it published in the literature? What's the frequency in NOMAD? Where is it located? Is it in a hotspot? Coming together with all of those codes and classifying it as benign, likely benign, uncertain significance, likely path, or path. Then there's interpretation. This is determining whether the variant that you have just classified is the cause of a patient's disease or if it's reportable. I have to emphasize this. A variant should be classified in the same way, no matter what, irrespective of a patient's phenotype. You should be searching the literature. You should be looking for computational predictors. You should be looking at the frequency. It should be classified. If a variant is pathogenic, it's pathogenic no matter what. I will say the caveat, oftentimes laboratories do not count the case in front of them. So the person that the variant was identified in, unless there's compelling evidence to do so. So if the patient has, and this one's when you would factor in phenotype, if the patient has a very specific phenotype that's PP4 worthy, if the patient has been determined to have a de novo status, if there's segregation within the family, you can count that when classifying the variant. Really, the difference here in a carrier screen, so an unaffected individual versus an affected individual, would come in interpretation. Asking the question, is this variant the cause of disease in my patient? If you're in a screening panel, there is no cause of disease in a patient, but you set rules ahead of time of what things should be reported. So in general, at least within the United States, it's accepted that in healthy screening, we really only want to return likely pathogenic and pathogenic variants in certain genes with a lot of evidence that are highly actionable, and we'll do actionability curation later on. So that's really when you would have the difference of if you should report variants based on the phenotype of an individual, not you should classify variants based on the phenotype of an individual. You should always classify a variant the same way. It should be pathogenic no matter what. It's just whether it is the cause of someone's disease or not, and whether you would put it on a report. Hopefully that's clear, but that's often a very common misconception where someone will say, oh, this variant is pathogenic in this patient and benign in another patient. That's not the case. It is always pathogenic. It's just it is the cause and it's a positive report in this one patient. And it's not the cause, and maybe it's an incidental finding in this other patient. And so it might not even go on their report because it might be an incidental finding for this other patient. So that's just a very important difference that's often confused. Okay, another general classification question. What's the best approach when a variant meets both pathogenic and benign criteria? So for example, strong family segregation, but unexpectedly high population frequency. So that is the difficulty with the 2015 guidelines, that they are combinatorial and often, and they say when you have pathogenic and benign criteria, it should just be stuck in a VUS, which really isn't necessarily the best thing to do. And that's why with the new guidelines, they're going to be using positive and negative points for benign being negative and pathogenic being positive to really give the correct weight for benign and pathogenic criteria. But we have to work within these current guidelines for the moment. Um, and so, at least within our expert panels, we tend to weigh the strength of the evidence. For example, if a variant's very high frequency in NOMAD, but has a damaging computational prediction, in theory, that might meet BA1, which is a standalone benign criteria piece, and PP3, which is a supporting piece of pathogenic evidence. They tend to discount that pathogenic or damaging computational predictor because it is so high frequency in a population. So in general, high frequency in a population is a standalone criteria for classifying a variant as benign and shouldn't be discounted. So in the example that the questioner provided above, that even though there's strong family segregation, if it's unexpectedly high in a population, that probably is happening by chance. It's probably too frequent to cause disease. So I would say high population frequency is probably one of the top pieces of evidence to suggest that a variant is benign, whereas a measly computational predictor from a missense predictor with one little piece of supporting pathogenic evidence, if a variant is present in 5% of individuals in a population, should probably be discounted, and that variant should probably be classified as benign. But there will definitely be more clarity in the new guidelines with different positive and negative weights for benign and pathogenic criteria that can be summed together within the new guidelines that'll make it a bit simpler. Okay, more general classification questions. Why does the numbering of the ACMG AMP criteria, for example, PS1 versus PS4, not imply differences in weight within the same strength category? So I will say, and I work very closely with those individuals that develop these guidelines, like Heidi Ream, and she has admitted that the numbers that they used in the codes were just entirely random. They did not realize that the codes would end up being used in so much isolation like they do. So they really just listed all of the evidence for a particular type, so population data, and went through and listed all the codes like randomly numerically, and didn't necessarily say like, oh, number one is most important and number four is least or something like that. It was just entirely random. Unfortunately, they just didn't realize it would take off in the way that it did. So the only things that they really speak to, and I'm sure you know this, is the first letter is pathogenic or benign, and the second letter in the code speaks to the strength. And that was just the decision that they made at the time. And the codes will definitely be different enough to differentiate between this version of the guidelines and the new ones within the new points-based system. Okay, given that variant interpretation evolves with advancing knowledge, is there a defined timeline or trigger for revising guidelines? It's a great question. As you've noticed, it has been now going on 11 years since the last publication, and it is a big paperwork and administrative headache to assemble temporary groups. And so to try to get around that and become more nimble and releasing updates to guidelines, ACMG, AMP, ClinGen, and CAP have come together and they have created an official group with public members in hopes that they can more nimbly update their guidelines every few years, much like the ACMG Secondary Findings Committee, which releases new gene lists every year, instead of waiting 10 years in between updates. So really the goal is maybe ClinGen will refine some of these suggestions, much like they have done and published for the previous 2015 SVCV3 guidelines, and that this group will maybe release minor updates every couple years so that there isn't such a major update 11 years apart. So that's the hope in the future, but that still remains to be seen once this new version is released. Okay. Next general classification question. Given that adherence to these guidelines is voluntary, under which specific circumstances could a board-certified geneticist's professional judgment warrant deviation from the standard classification of a variant? It's a good question. As I said, I'm a laboratory geneticist, and so I am using professional judgment relatively often. So while the guidelines were created to promote standardization and classifying variants, and multiple studies have shown that these guidelines are widely adopted in surveys and also facilitate a more standardized way of classifying variants. They are created to be flexible enough to use professional judgment. And one of those pieces includes modifying the strength of the codes, for an example. ClinGen already does this, but labs also can do it. And there is one suggestion to try to be consistent when possible. Of course, there are difficult variants, and my variant analyst will come to me and say, for this variant, here is this evidence. Do you think we should apply it at a moderate level or a strong level for particular code? And then I'll weigh in on that. And I would say that's where expert judgment comes in the most is, oh, is this phenotype specific enough to give a higher weight for a de novo code? Is really the weighting of the codes. But that flexibility of expert judgment, and Heidi will say this all the time, is built into this framework and is encouraged. You should use your brain when you're classifying variants, not just automatically type in codes. So that's definitely built into the framework and encouraged, at least in a standard way. You should never say like, this feels like a pathogenic variant, and then just like upgrade it to pathogenic without enough evidence. We try to discourage that. But if you have evidence and you're trying to do it in a standardized way that makes sense, you should definitely do that. Okay, someone now asked a question about transcripts, which I get are definitely confusing. I'm confused with the different types of transcripts. There's information relating to main, which I thought was the one to use, but now I also see clinical main, and someone also mentioned LRG. It's a great question. In the past, transcript literature was kind of all over the place. And so here are the ones that you referenced. So main is matched annotation from NCBI and EMBL EBI. They have multiple transcript types. They've come together and they've harmonized their transcripts, which is great because different resources are using different things. I would say largely within the clinical space and literature, they were using RefSeq, which is the NCBI product here, whereas computationally derived things were using EMBL EBI. So like Nomad uses EMBL EBI. So main select is often the one that people refer to as main, and that's often the one with the most biological evidence, if possible, and is generally suggested to be used. Most all genes have one main select transcript. However, there are some genes that have additional transcripts, and those are designated as main clinical plus. And those are additional transcripts in which likely pathogenic or pathogenic variants have been identified that are not present in the main select transcript. And these are often used by clinical labs for completeness because clinical labs do not want to miss any pathogenic or likely pathogenic variants. And if a potential well-known path or likely path variant that would be present in a coding section of a clinical plus transcript is non-coding or deep intronic or something like that on a main select transcript, it could easily be filtered out in a clinical pipeline. So that's why clinical labs try to work towards completeness and not just using the main select transcript every time. So that's why you may see that is that certain genes have multiple main transcripts in that way. LRG transcripts, which I think is locus reference um, genotype, if I remember correctly, were an old curation effort. And this was done by the RefSeq team as a precursor to main, and those should no longer be used. So those might still potentially be in the literature for LRG transcripts, but you really should be working towards like using the main transcripts now. And I will say that both RefSeq and Ensemble have their designated main transcripts, which should be equivalent. So you can pick your favorite. If you like to use NCBI's RefSeq transcripts, you can use the mains from RefSeq. If you like to use EMBL EBI's ensemble transcripts, you can use the main from the ensemble, and those should be equivalent. So that's okay. Okay. The next question is about education. So, do you foresee the need for formal certification or accreditation for variant and gene curators, similar to other clinical laboratory roles, to ensure long-term quality and consistency across institutions and regions? So, I will say within the US, I have seen more and more master's programs, particularly for variant science, springing up, which is great because they really do deep dives. on how to classify variants. It's really like a master's in genetic counseling, but a master's in variant science. So they teach about technology, they teach about guidelines, they teach about curation, transcripts, like all of the things that we're touching on, but in really deep depth. And I think they even potentially have rotations like in clinical labs for those folks, which is great. I will say additionally, employees, at least at US based clinical labs, do need to register continuing education credit. So even all of the employees in my clinical lab need to have at least 12 hours of continuing education credit every year, which often involves attending seminars, um, attending conferences, um, performing certifications for credit online, like those things. So that happens. And then also we have annual competencies to assure training and quality. But I would say the biggest step in this direction is those master's programs for variant science. I have come across many variant scientists now as this is becoming more and more of a solidified career path, which is amazing. I think I love variant science. I think this is the biggest step towards that. Okay, so then we had some questions about communication with clinicians. So what's ClinGen's recommended language for explaining a VUS to clinicians or researchers? This is a great question. Everyone's always like, ugh, what is it's a VUS? Is it really benign? Is it really likely pathogenic? What do you think? And there is a big range here. So we try to use numerical cutoffs here. So ACMG and ClinGen try to explain variant categories with likelihood of the variant being pathogenic or benign. So when you say that something is likely, so either likely benign or likely pathogenic, there's a 90 to 99% confidence that that variant is what you're saying it is. So if you're saying likely pathogenic, it's 90 to 99% confident that that variant is actually pathogenic. And in many situations, in the literature, we've shown that likely pathogenic variants move to pathogenic over time. Same thing with benign variants. If you're saying something's likely benign, it's 90 to 99% certain in your eyes that it's going to be benign. And we've shown that many likely benign variants move to benign over time. However, look at the giant range for VUS. That's kind of a mess. 10 to 90% likelihood that a variant is either pathogenic or benign. It's just a giant bucket. And so oftentimes, that's why people are starting to discourage returning VUSs except in very specific circumstances, or just putting them in a large table. Because what if you're in the 10% section? You wouldn't want to act on that. That's actually probably much closer to being a likely benign variant. But if you're in the 90% section where you just needed one more piece of evidence to get that variant to likely pathogenic, that's a really different VUS. And so that's why in the next set of guidelines, they're actually suggesting that laboratories tier VUSs, and they're suggesting the range of VUS high, VUS mid, and VUS low. And VUS lows are really at that 10% likelihood that they're almost towards benign. VUS mids really, they're just stuck in the middle. There's not much evidence about them at all. And VUS highs are the ones that are quite close to being likely pathogenic. And I think I have the publication on another slide, but there was a very thorough analysis done of laboratories who have sub-tiered their VUSs for 10 to 14 years, and they have found that VUS lows get downgraded and VUS highs historically get upgraded over time. And so that's why this has been really helpful for them, because it also prioritizes which VUSs you might want to reevaluate over time. And this is related to this question, is how could clinicians communicate with patients when variant classifications shift, for example, from VUS to pathogenic? So I'm not a patient-facing clinician myself. As I said, I'm a laboratory geneticist, but my colleagues often emphasize that scientific literature and our knowledge of genetics is changing and growing all of the time when they talk to patients. And so as more published evidence becomes available, a VUS may change to a more certain or sure status of pathogenic or benign. And so they often will emphasize that. And clinicians will often, after a certain amount of time, request that a laboratory reevaluate a variant for this reason, just the fast-paced nature of genetics and that things are being published all of the time. And I think something that's also important that many clinicians have told me is they often emphasize that they are going to continue management based on the symptoms and the potential um, phenotypic diagnosis of a patient with a particular condition, um, regardless of what's going on with their VUS variant. And they may factor the variant in second if it becomes more certain. So if it's really known, for example, that an individual has Pendred syndrome, this is a good example because I've worked in the hearing loss domain. So Pendred syndrome is hearing loss, and oftentimes there is like an additional ear phenotype of enlarged vestibular aqueduct and potentially some thyroid issues. Notoriously within this disease area, even though it's an autosomal recessive condition, in a high percentage of patients, we only find one variant. And so in this case, when a clinician is really sure that an individual has Pendred syndrome, they will diagnose them with Pendred syndrome and manage their ear and their thyroid condition, regardless of whether they ended up with those two biallelic variants in SLC26A4. So this is often the case when I talk to clinician friends. Um, both emphasizing that literature can really push a variant towards certainty in the future, and so that we should continue to evaluate it over time, and that might be why something shifted from VUS to pathogenic, and also reassurance that they are going to continue to manage at least the known symptoms of the patient in the meantime. Okay, a question about reclassification. I'm cognizant that try to go a little quickly so we can have some live questions. So at what point should a VOS be reevaluated or reclassified? So this question's up for debate in the field. Clinical labs, practically speaking, often don't reclassify a variant unless they observe it again. But in general, in the literature, it's shown that it could be worth looking at variants every 2 to 3 years. It has often been helpful to look at cases every 2 to 3 years to see if they have a new cause of their disease. And so it's a bit of a similar timeline. However, unless a clinician comes in and requests a variant to be reevaluated for a rare variant, oftentimes clinical labs don't look at it again someone else unless they detect the variant in someone else, because they just have thousands and thousands of variants and they can't be recurating them all the time. But in my clinical lab, we do set classifications to expire. So if you were to observe it again, you would have to reclassify it based on a certain period of time. I think our classifications expire annually, if I remember correctly. So next question, in our practice, we encounter a high number of VUS, partly because African populations are underrepresented in current genomic databases. What would you recommend as a practical approach for keeping up with emerging evidence and facilitating the reclassification of these VUS over time? It's a great question. And VUS burden is particularly high and difficult, especially in those populations that are underrepresented in databases and scientific literature. But there are a few ways that you can keep up with VUSs. So if your variant is a ClinVar allows you to follow a variant and they will notify you if a classification changes. So I do suggest to make an account and follow variants if they are of interest to you. And as I said before, it's been shown that if you sub-tier VUSs, you have a better handle on which ones will be upgraded or downgraded. And so those with VUS with evidence leaning pathogenic or benign have been shown to be more likely to change over time. Here's the publication PubMed ID for that. So if you are within a laboratory, you could potentially sub-tier your VUSs, even if you don't use that wording on reports. At least internally, you would know which ones to review more often over time. And if you're a clinician, you might just want to follow a variant in ClinVar. You can also follow a variant, if I remember correctly, on the ClinGen website. And you could set up like some sort of automated literature search, but I think following a ClinVar variant is probably your best bet there. Okay, so questions for related to ClinGen variant curation. So given the precautionary and interpretive complexity of variant curation, how does ClinGen ensure that curators are sufficiently mentored before working independently? And are there structured mentor, mentee, or competency-based pathways in place? It's a great question, and yes, because we are recognized by the FDA in the US, we have a really defined, standardized training procedure. So we have two sets of training. Step one is general variant training, where really the curators go through something very similar to what you did this week, where they have to read a certain number of papers and then they have to attend a live training for ClinGen volunteers. They then get assigned to an expert panel and they go through step two training, which is disease specific. So this is really starting to understand the specifications of that particular VSEP. And so they'll read their paper, they'll work through their criteria specification document. And then a requirement is you need to complete 5 variants in a logbook, or 3 if you're a laboratory director or a variant scientist, but you need to have a letter from your job to say that. So you need to complete those variants in a logbook alongside a variant curation trainer. So I am a trainer for multiple expert panels. I will review the variants that those individuals classify, give them feedback. The expert panel will also give them feedback to really make sure that individuals are trained. Okay, next question. Has ClinGen considered a campus ambassador or trainee outreach program to engage medical students and other future users? It's a great question, and I will say that ClinGen hosts a variety of workshops for different end users. Within reason, we are funded by the government, so we only have so much funding, but we often respond to requests like how I was approached for this workshop. So if anyone has any particular ideas, feel free to email me or clingen@clinicalgenome.org. And one of the most powerful things we've done is train the trainers workshops, where we really will go to another country or another region and really extensively train those individuals who can then go and teach and further train the workforce within their area. So I've definitely done that too. And I will say that I am a faculty member for local medical schools and run a residency program there where I teach internal medicine residents about genetics. Okay, general questions. Can you talk about current potential research areas for variant curation where potential researchers in Africa can explore? So I think there's some really important work to be done. And some of this is exploring a few pieces related to monogenic conditions. So one question is genotype phenotype correlations. Are reported phenotypes in the literature that are consistently, skewed representation consistent with what you observe in your patient cohorts? Should the phenotypic spectrum be expanded? That's really important to start to ask those questions and publish that information so that patients really have equal chance of being diagnosed all throughout the world. And then what are the most common causes of heterogeneous genetic conditions in your population? I'll go back to hearing loss. We know because European populations are very heavily characterized. We know that GJB2 is the most common genetic cause of hearing loss in European populations. There's some really good work that's been done on this in hearing loss in African populations. What's the most common cause of hearing loss in African populations? Because there's like 160 genes associated with hearing loss. So questions like that are also very, very valuable for the patients that you end up having in front of you. So I think those are two really interesting research questions that really are still underexplored in many populations. Okay, so we've got 6 minutes left. I'm going to escape out of this and stop sharing, and then I am going to start by asking some or answering some questions in the chat. But then, if people want to start raising their hands, we have about 6 minutes, so we don't have a ton of time. But I'm happy to answer as many questions as I can. So the first question, I'm going to start at the bottom, then I'll scroll back up. When will the new ACMG guidelines, SVC v4, expected to be released and published? It's a great question. It's a moving target. I think as of now, we're trying to set policies for ClinGen expert panels, and we're hoping that this would be about October 2026, so October this year, but it may be a little bit later than that. They have to, once they have finished the guidelines, they have to send it out for member comment to all of the different advisory boards that are involved in this. So that can take a month, it could take 3 months, even more than that. So they're hoping to be by the end of this year, but we're not sure exactly at this point. Okay. So, another question, should ACMG guidelines for variant classification be extended to variants found in regulatory regions? So enhancers, transcription factor binding sites, et cetera, or remain focused on coding regions? And how might multimodal prediction tools such as alpha genome shape future approaches to interpreting these variants? That's a great question. And I will say that the ClinGen variant classification working group is starting to tackle this a bit. So Nicola Whiffen, based in the UK, who was really instrumental in discovering many of the non-coding genes, the RNU4 attack and RNU4 and RNU2 genes associated with developmental delay, has published some suggested guidelines for non-coding variants and classifying variants in non-coding variant or in non-coding genes. So please take a look at that guidance. Is Nicola Whiffen is her name. Okay. Another question, reputable source has already been excluded and no longer applied, or are there any conditions in in which it hasn't been applied? I would say in general, ClinGen has now said to exclude the reputable source criteria. There pretty much are no times when it is applied anymore. Okay. How do we balance rules with professional judgment? It's a good question. I would say I start with rules and see where the rules get me. And if I feel that in my experience something is underweighted or overweighted, but I will say in general, and this is just me as a laboratory professional, I tend to be very conservative in classifying variants because of the potential damage that can be caused in classifying a variant as likely pathogenic or pathogenic and having to come back and say, oh, I'm sorry, you might have taken medical action on this variant, but it's actually uncertain significance. I'd much rather start with a variant being uncertain significance if I'm not certain about it than classify it as likely pathogenic and have to downgrade a variant. So I would say in general, I tend towards being more conservative, both in applications of the rules and expert judgment, but it is a bit of a balance. And I would say that consistent application, I think, is key. And so even if we have deviated from the ACMG AMP guidelines, we write a standard operating procedure to make sure we do it in a standardized way in our clinical lab. And then the one at the top that I saw is, what do we do when there's inconsistency in expert guidelines? Um, what would you follow? Yeah, that's a great question. I would say when there's inconsistency in expert guidelines, I tend to try to get, this is me being involved in ClinGen. We tend to try to get all the individuals together and come up with consistent guidelines. So I would say if you notice that there are inconsistent guidelines, and this is an example here, that you should reach out to ClinGen so that we can try to work together to share our resources and come up with more consistent guidelines. But I would say that in general, I tend to try to follow the group that has the most representative and diverse expertise internationally in a particular disease area. And oftentimes the groups that are a bit more conservative for the reasons that I said before, that I worry about overclassifying variants. But I agree that it can be difficult sometimes to, especially if it's not your disease area of interest. Or cancer is not my disease area of expertise. So I do tend to defer to Enigma, although those rules are a bit difficult to follow. Okay. And then another question is naming of variants. Do we have any resources to take one through this process? and any tips on how to navigate from the gene sequence to the protein sequence and vice versa. Yes, so the Human Genome Variation Society has a website where they suggest how to use HGVS nomenclature. And so they give you different guidance based on the type of variants. I will say that much software does follow, to the best of its ability, this guidance at this point in time. And oftentimes there are different pieces of software that if you put in a genomic position, you can get, or a cDNA position, you can get a protein position. And so one of those is actually the ClinGen allele registry. So if you go to reg.clinicalgenome, that can often help you correctly name variants. Okay, so I know that there were lots of really wonderful questions. We are at time, and I want to thank you all for such wonderful questions and such excitement about variant curation. It really heartens me to find other individuals who are like-minded and as excited as me about variant curation. So thank you so much for your great questions and for your participation this week. And I will say that expect an email from me on Monday. We're going to start gene curation, which I also am very passionate about, and I want to make everyone excited about gene curation because I think that's forgotten sometimes. So that's what we're going to be talking about next week. Continue with the great questions and look for an email from me at the end of the week. And I'll turn it back over to you, Wafa, if you have anything.
Thank you so much. As you requested last time that you will send the survey on Monday, we will close it at 5 p.m. Thursday. Okay, so
Yes.
Dr. Marina can collect and answer all your questions. Thank you
Yes.
so
Thank
much.
you so
Thank
much.
you for your time, Dr. Marina.
Thank you, everyone. Have a wonderful weekend, and I will talk to you next week.
Yeah,
Bye.
thank you. Bye.